Remember, physics examination being the toughest of all the science examination, mostly the students are worried about what kind of questions will be asked. So let us just look at the important questions that you have to prepare. Now, I have categorized these chapters, number one being the force, then work, power, energy, machines, light. I know that there are refraction through glass slab, prisms, lenses, and then we have scattering of light. After that, we come to sound. Of course, in some books, there are individual chapters, but let us just keep light as a whole. Sound, then electricity, we have household circuits in that, and then electromagnetism, calorimetry, and the modern physics. So, if you look at these topics, how do we study chapter wise properly? There is no hard and fast rule about the kind of questions that will be asked. Everybody knows that in your section 1, that is your section A, there will be 40 marks. In that, you have the first question. Question 1 is going to be your MCQ, and then we have question 2 and question 3. They will be divided into subparts, and some of them will be like 2 mark questions each. Now, in these 2 mark questions, they can ask you direct questions. Some of them will be definitions, but mostly understand the concepts well, because they will be asking application type of questions where understanding of the concept is very, very important. Like, for example, if we talk about force, the moment of force. If we talk about moment of force, we need to know the formula for moment of force, which are the factors that it depends upon. It depends upon magnitude of force and also the perpendicular distance of the line of action of force from the axis of rotation. So they will give you some diagram based question, or they will just ask you something that is dependent upon the reasoning type of question. So these all in all, they will be comprising of 40 marks. Then we come to section B. In your section B, you have to write any 4 questions, and you know that. So when you are getting your paper in hand, you need to look at your question 4 onwards. You have to see which are the 4 questions you want to pick up, because you want to score the maximum marks from these. All right. So now that we understood the pattern of the marks, also understand that each one of these 4 questions, they are going to be 10 marks each. Pattern that they have is 3 marks, 3 marks, and 4 marks. All right. So some of them will be diagram based questions. Also, I'll tell you exactly what type of questions you have to study from here. Now, work, power, energy, and force, you will have from these mostly, of course, conceptual questions will be there. There will be numericals. At least one numerical can come on these. And these numericals, if it is force, it will be depend upon the torque. Okay, the diagram will be given. You have to look at which force is applied at which point and what is its perpendicular distance of the line of action of force from the axis of rotation. In work, power, energy, they can be diagram based question, but for work, remember your positive, negative, zero work. These are the important facts that you have to know. For power, work upon time is the formula, and power is equal to F into V. That is the second formula. Yeah. So for this power, you can have mostly the numericals, short numerical like 2 mark question. For energy, remember the type of energy is the mechanical energy, is the potential energy, the kinetic energy. In potential energy, the elastic potential energy, gravitational potential energy, and then we have kinetic energy, which is the energy due to motion. We have the formula for kinetic energy, half mv square, and for your gravitational potential energy, we have the formula potential energy equal to mgh. We come to the law of conservation of energy. In law of conservation of energy, you must know the initial potential energy, how it is converted into final kinetic energy. A body is thrown upward, it reaches the highest height. What happens at the highest height? Kinetic energy becomes zero. So all of the kinetic energy has got converted into potential energy. So you need to know these things, and also the graph where the potential energy, kinetic energy, the graph goes this way. So if this is energy axis, this is in joules, and this is the height in meters above the ground level. And this is your x-axis and this is your y-axis. You will have one graph this way, one graph this way. If I call this as graph number 1, this as graph number 2, and this is graph number 3 this way, then you have to recognize which one of these is potential energy, kinetic energy, and the total energy. Understand the graph, because question based on this can come. Also understand that law of conservation of energy is important. They will give you initially the body is thrown up, so they will give you initial velocity, it will be given to you, mass will be given to you, and the energy possessed by the body over here is going to be kinetic energy, which is half mv square. Now this is going to get converted into potential energy, and the potential energy is given by mgh. Now they will not give you any data for height or whatever. They will ask you, if this is the highest point, they will ask you what is the potential energy at the highest point. So you are going to say, by the law of conservation of energy, the final potential energy is equal to initial kinetic energy. So even though you do not know the value of h, you can just say half mv square. You already have the value of mass given, and you know the value of v is given. So initial kinetic energy, so you will say half mu square, and substitute this value over here, and you will get your value of the energy in joules here. Okay, so these are some of the questions which you have to prepare yourselves. Now, when it comes to the machines, now remember the machines, you must know all four functions. The definition of machine is important, and then we need to know mechanical advantage, velocity ratio, and the efficiency, work input, work output, power input, power output. Know those concepts well. Okay, and once that is done, you can have the levers, class 1, class 2, class 3. These are the three types of levers you should know. Dependent upon the fulcrum and the effort point and the load, we can have increasing or decreasing mechanical advantage. If you look at a simple thing like class 1 lever, you know the fulcrum is in the middle. We have the load at one side, and the other side there is effort. So if I want to increase the mechanical advantage, what I need to know? The mechanical advantage for the lever is effort arm upon the load arm. So I need to increase effort arm or decrease load arm. So how do I increase the effort arm? If effort point is here and this is where the load is suspended, I will move this fulcrum out here. Now when I do this, what am I doing? I have increased the effort arm from this much to this much. So what has happened? The effort arm has increased. The load arm has decreased. Earlier load arm was this, now it is this. So definitely in the denominator, if you have a lesser number, it is going to give me increased quotient. So MA becomes greater by increasing the effort arm and decreasing the load arm. So these are some of the concepts you need to know well. If it is your class 2 lever means it is fulcrum here, and then we'll have load in the center and effort will be like this. Now here effort arm cannot be increased because the maximum effort arm will be the end of this lever. So if they give you the length of the entire lever for from here to here, that becomes the value of effort arm. Now, if I want to increase the mechanical advantage, I cannot increase effort arm. So what I need to do? I have to decrease the load arm. So what will I do? I will place the load as close to the fulcrum. So the fulcrum is here. The load has come here. So initially the load arm was from here to here, but now I made it from here to here. What have I done? I have decreased the load arm. Effort arm has remained the same. Okay, so these are the situations which you have to think out. So focus on these things regarding the levers. Also, the pulley system, you need to know the single fixed pulley, the single movable pulley, and the block and tackle system. In block and tackle system, you'll have the upper block, and then we have the lower block. So you need to know from here what will be the velocity ratio just by giving the diagram like this. And you need to start, if they ask you to complete the diagram, start from the effort. Show the string and let it go backwards. Let it go this way, and this way. Okay, show the tension like this. So the load is spread over 3 segments of the string, and this one being the effort. This is T, this is T. Each one of these are the upward tensions. The load is equal to 3T, whereas effort is equal to 1T. Mechanical advantage ideally would be load upon effort, which is 3T upon T, which is equal to 3. Okay, now remember, in reality, your velocity ratio and the ideal mechanical advantage, their value is the same. In this case, it is the number of pulleys, that is number of strands on which the load is supported. So ideal mechanical advantage will be the same as velocity ratio, but due to the friction and the weight of the lower block, this part, the weight of it is going to reduce the mechanical advantage. In block and tackle system as well as the single movable pulley, the one fact that reduces the efficiency or decreases the efficiency is the weight of the lower block, because the lower block cannot be weightless. Remember that. And then you should know simple numericals of 2 or 3 marks. Definitely one of them will come. So you must know the pulley system properly. When it comes to refraction, all the facts, all the concepts, all the definitions you should know very well. In glass slab, you will have the lateral displacement when the ray goes from denser to rarer, rarer to denser, the way it travels, and it has to be monochromatic ray of light. Okay, when it comes to the prism, again you will have the angle of deviation. Later on, we also come to the formation of spectrum. Okay, when we have a polychromatic ray of light, all ray diagrams here, they are important. Ray diagrams, you will have the questions based on these. They will also be simple numericals, and in simple numericals you will have the calculations of mu connected with real depth and apparent depth. So you need to know these formulas. Mu is equal to real depth upon apparent depth. Also mu is equal to c upon v. You need to know how this works and how to apply them in the formulas. When it comes to lenses, again you'll have ray diagrams. They will ask you to draw the diagrams, and you need to also know by the description of the image. Like if it is real, it has to be inverted image. So if it is diminished as well as real and inverted, then where is the object placed and what is the nature of lens? If I have real image, can I ever have concave lens? No, concave lens always gives virtual image. So real image means I have to take convex, and then it has to be diminished. So where should be the object? The object should be beyond 2f. So you need to remember this. If it is virtual, there are two types. Either it will be magnified image or it could be diminished image. If it is virtual and magnified image, then it has to be your convex lens. And if it is virtual and diminished upright image, then this has to be concave lens. Okay, this is convex lens, this is concave. So you need to know this, and then you have to remember the formula on which the image distance, the object distance, and the focal length, those calculations also will come in that. Prepare them. Scattering of light by and large is a ratto type part of the syllabus. No numericals will be based on that, but you must know what are the factors on which scattering depends. The intensity of scattered light is inversely proportional to the wavelength to the power 4. So more the wavelength, less will be the scattering. Now from the Vibgyor, you know that violet is having 4000 angstrom unit as the wavelength, red one is 8000 angstrom as the wavelength. So maximum wavelength is red, so it is going to get scattered the least. Violet has from the visible spectrum the least wavelength, and so its scattering will be maximum. So based on that, a number of give reasons will be there and objective questions would be there. Yeah. Then we come to sound. In sound, you have to know your basic longitudinal waves, the transverse waves, and the echo. Most important is the concept of echo. What are the conditions for echo? Also, you have to remember the formula V is equal to 2D upon T. When there is just an rigid object, it could be the building, it could be the cliff, and a person over here, he claps the hand, and the distance here is D, and the reflection happens, and the total distance is D plus D, and that is 2D upon the time taken. That would give us different numericals based on this. Sometimes there will be a person who will be firing the gun, and there would be another person who's listening to that. So this person will hear how many sounds? He will hear two sounds. Which will be the first sound? First sound will be because of the direct traveling of sound. And the second one, when the sound goes this way and then gets reflected and comes back. In this case, formula using V is equal to total distance, okay, upon the total time. Now, in total distance, it will be if this person has fired, if this distance is d1 and this distance here is d2, from here to here and from here to here, then the total distance will be here d1, then comes back over here, that is again d1 and plus d2, and that upon it will be total time. Okay, so it may not always be V equal to 2D upon T. It depends upon the situation. Understand the concept well, understand the situation well. And most important thing, many children say, ma'am, we don't like the numericals. You don't like the numericals because you don't put yourself in that person's shoes. If you put yourself in that person's shoes, it is very, very achievable. Okay, in electricity, all the definitions, concepts are important. Go through them. All SI units are important in each one of these chapters, very specially for this chapter here and calorimetry. The SI units are important, the concepts, the definitions are important. Then here, the circuit diagrams are important, the numericals on circuit diagrams are very important, so do them thoroughly. In electromagnetism, you have to know the diagrams. They will give you the diagram and they'll ask you to apply the different rules that you learned. Which is the first rule? It is the Orsted's experiment. So that will be regarding the compass needle, which is kept above the current carrying conductor, below the current carrying conductor. The observations based on that can be asked. After that, you will have the right hand thumb rule. You have Fleming's left hand rule, right hand rule, clock rule. Okay, so whole lot of diagram based questions are important in electromagnetism. Ultimately, it ends up with your DC motor and your AC generator and the transformer. So in DC motor, your diagram based questions again are important. They will ask you what is the direction of the force experienced by of the if the coil is ABCD, what is the force experienced by ABCD, like those types of questions they will ask you diagram based, or they can just ask you to draw the diagram. You should be able to draw this diagram in just 2 minutes. You can practice these so that a totally label diagram you can finish in 2 minutes. Your speed is also important. AC generator, again, diagram based questions. You will be asked what is the direction of the current in the external circuit. You can be asked what happens when, like if the number of turns is increased or number of turns is doubled, then what happens to the EMF? So those observation type of questions will be asked either for this or for this also. In a transformer, you should know the two types of transformers. Which are the two types of transformers? Step up transformer and step down transformer. In step up transformer, what happens in the primary coil? What happens in the secondary coil? What is the turns ratio? What is the number of turns compared to primary? How many turns? Will the number of turns be more or less in step up, step down? You need to know that. You need to know which coil will be thicker in step up transformer, step down transformer. Why? So you need to prepare these questions. Also, you will have to learn how to increase the efficiency of the transformer. How will you increase? That means how will you prevent the loss of energy? All right. So these are the types of questions you have to prepare for yourself for this. Later on, we come to calorimetry. Calorimetry is all-time favorite chapter. You cannot really predict what type of questions will come, but in calorimetry, your SI unit, your definitions, okay, the specific heat capacity, the thermal capacity, the specific latent heat of fusion, you need to know. So this is the learning type of work. You need to know for each one of these SHC, the thermal capacity and specific latent heat of fusion. You need to know even the SI units, and they will ask you if it is joule per Kelvin, then what is the quantity that is measured by this? So something like this, you need to know how to proceed with. Okay. Now, after that, we come to the method of mixtures. We come to method of mixtures where something hot is added to something cold. So there will be two bodies or three bodies. If there is water in which a hot body is added, then you will have the calorimeter and it will have the water, and we will add, let us say, metal piece is added to the water in the calorimeter. So you will be given mass of the calorimeter, mass of the water, and the mass of the metal. Then there will be SHC, specific heat capacity. It will be supplied for the calorimeter, it will be supplied for water, it will be supplied for the metal. And then we'll have the initial temperature and the final temperature, and we'll have the delta T. So if you make the columns like this, you'll be able to find out what is delta T for each one of them. And then we have to simply use the principle of calorimetry, and that will give you heat gained by calorimeter and water is equal to the heat lost by metal. Here you will see how many quantities are there. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, so you will see T2 will be the same for each one of them. From these 9, they can ask you any one. If there are total 9, they will be all 8 will be given, and they will ask you which is the one which is not being given to you. All right. So you should be able to play with mc delta T of calorimeter plus mc delta T of water is equal to mc delta T of the metal. So if you get organized this, then the calculations will be much, much easier. Now that finishes the heat capacity, specific heat capacity and the heat capacity. But then following that, we also come to latent heat. Now you need to know the concept of what is the latent heat, why that heat is not recorded on the thermometer. So what happens to the potential energy? What happens to the kinetic energy of the molecules? This part has to be done properly. Based on the first part, that is specific heat capacity as well as specific latent heat, you will have number of even give reasons. So you can be asked questions based on the units, you can be asked the give reasons, and they will be, of course, all-time hot favorites are the numericals. Practice every type of numerical. Also, practice the numerical where I have electrical energy supplied. If I have a heater which is heating the water, the electric heater is going to take the power into time, that will be the energy consumed, electrical energy consumed, that is going to get converted into heat energy, and it is going to raise the temperature of the water which is being heated, and for that the formula will be mc delta T. So anytime there is electrical appliance, remember P into T is equal to mc delta T. You have to use this formula and you have to get through. Learn all the give reasons effectively. Learn to mark the keywords. Look at my videos of 10 standard playlist. You will see number of different types of questions that can be asked. I've discussed that. Now, lastly, we come to modern physics. Now, in modern physics, remember the structure of nucleus. That is important. Your alpha, beta, gamma. Their properties are important. Which has got the highest ionizing power? Which has got the highest penetrating power? What is the comparison of the ionizing power? If I have ionizing power of alpha is to beta is to gamma, then it is going to be 10 to the power 4 is to 10 square is to 1. Because bigger the particle, more is the ionizing power. If it is penetrating power, then alpha is to beta is to gamma is just the reverse order. 1 is to 10 square is to 10 to the power 4. So now you understood these are the comparison type of questions. They can ask objective type of questions. They can ask name the following radiations. They can ask. But most important is also where they will ask you numericals. Now, in numericals, when alpha particle is gone, what happens if you have XAZ? It is going to lose alpha particle, it is going to become A minus 4 and Z minus 2, and plus it will be alpha particle is helium 42. Okay, then if it is beta, then you will have, let us say, PAZ is going to become Q, and plus it is beta particle. Beta particle is an electron. Why does it come from the nucleus? Do we have electrons present in the nucleus? Remember what happens to neutron, how it splits into the proton and electron, and how that electron is thrown off from the nucleus. So electron is denoted by this. So your A remains A, that is the mass number, and the atomic number, this becomes more by 1. It increases by 1. So using this, they will ask you to complete the equations. Sometimes they will give you the end product and they will ask you what is the mass number and the atomic number of the parent nucleus. Okay, so basically these will be giving you the entire important questions of physics ICSE syllabus of 2025 so that you can get your full marks. If not full marks, always 90% plus you can obtain. So study well, concept, understanding, and application type of questions. Extremely important. Okay. So all the best for all of you. Do work very well. Focus on your work. Remember that proper recall at the proper time is extremely important. Go through lots of sample papers, lots of papers that are available even on the internet. Your teachers probably have given you the links where you can access the physics papers and the ICSE papers of ICSE schools prelims. Solve them. Go through the different ones and then see which ones are the ones which are repeated maximum number of times. Go through the competency based papers also and score really, really well to the best of your ability. And thank you for watching. Do yourself proud and your parents proud.